Addressing the problem of water by catch and store. The only thing that brings the water up here is rain. Mostly it's very dry, but we have to be ready for heavy rainfalls. If the ground is dry, it cannot catch the water and there is a lot of runoff water, which leads to destruction further down. So how can we hold it here? We can do earthworks combined with planting to slow down the water and to let it infiltrate the earth. The roots of the plant can hold the water and so it will stay up here.
These plants have to be protected because there is a lot of grazing animals around, sheep and goats. And we can do it with a fence, like here, because this is a demonstration site. Or you could do it by a holistic managed grazing that is accepted by the people. This method of catching and storing water is called water retention. And I want to explain now how it works in a bit more details. We are trying to slow down the water from the highest point that we can. This is why we put stone walls in this dry water channel. We have repeated this work every few meters. And now you can see these terraces have filled up with material brought by the water. This is also the reason why this tree grows so well. It is now a bit more than 6 years old. Now I'm gonna walk down this water channel to get an idea how this whole system works. If we wouldn't have built up these water breaks, there would be much more erosion. There is also erosion, but now this is leading to a terracing, which is feeding these trees with water. So we've turned the problem into a solution in a very simple way. We can also find patterns of water where it finds its niche and it's trying to destroy our work. And here we can do some work to be ready for water. Putting back the stones. Another terrace. Down here we can see that our water stream, the dry water stream, is going into a bigger water stream that's coming from there. And if you look at mountains, you will find this pattern everywhere. Water is gathering when it is steep and it's distributing in a delta where it's flat. Here we have done the same work because it's still very steep. This method is very simple and powerful for steep landscapes. Another stone wall right there with big stones and another stone wall there. These are the lowest stone bricks in this system before the water is directed out on contour. Water always wants to be level. This is why we have built up this swale. It is called a swale that will bring the water out on contour. This is about 60 meters maybe on this side and another 20 meters on this side. And the water is directed gently, and it's meant to let the water filter into the ground. Still, if there is a big water event, this swale, which is about 1/2 meter high, it will fill up and it wants to run over. So this place where water wants to run over has to be built very carefully. And this is exactly the place. It's called a spillway. It is wide and flat, so the water cannot get enough energy to destruct this swale. There is also an emergency spillway a bit further back there, which is 10 centimeters higher than this spillway here. So the water cannot get its energy to destroy everything here. This method is repeated in this terrace down here. It is hard to see. I'm gonna go down now. From down you can see it a bit better. And this method of catching and storing water by keyline design, which is a big topic that's following natural patterns, can help to refill the groundwater level, which is a huge problem down here in this valley. One more time. This is the swale. This is the first terrace that is working the same way like the swale. It's just a bit wider because the landscape is not as steep anymore. And there is a third terrace and the last terrace in this system that's going all the way back there. Before the water, wait, this is the terrace. Before the water is directed down into the valley. One more time, our earthworks, the swale and the terrace from another perspective. And here we are working with keyline design. This is a big topic and I'm not going into the details, but it's definitely something you should know about if you want to work with this. It gives you a very clear idea how to install something like that. This is the last terrace. It's a bit hard to see. Before the water runs over this spillway and is directed into the valley. So it is built to hold back the water here in place, and combined with the planting it can recharge the water level. This helps to keep our fountain happy. Another very powerful method of catching and storing rainwater is using the roofs and the streets, because from there it's very easy to harvest water. These areas are compacted and they give us 100% runoff. All the area with a compact ground can be used for water harvesting.
To see how powerful this method is, we make the calculation. So we have 1 square meter with 1 millimeter of rain. That makes 1 liter of water. Every square meter is 1 liter of water. We already connected some of the roofs by pipes, and we have at the moment 800 square meters which are connected. And if we multiply that with the average yearly rainfall, which is 580 millimeters by the source of MeteoBlue, then there are 464,000 liters which are falling to the roofs every year. This is 464 cubic meter, but we cannot harvest all of that. Because if there is a rainfall which is less than 5 millimeters, you cannot harvest it, it will evaporate. So we calculate with 60% of that number, which is 278 cubic meter of water. These are 278 of these white water tanks, to imagine a little bit better. And this could bring all the plants and the trees through the dry summer.
The rain falling onto the roofs is channeled through these pipes into a big water storage. And now that you know the number of potential rainfall that we can catch and store, you may look at it in a different perspective. Remember, there is nothing else that brings water up here into these mountains but the rain.
The amount of water we can yearly collect by the area of the roofs would give us almost 1,000 liters every day that we can use.
And there are more roofs that can be connected to this water harvesting system. This is the place of the water storage. The cistern is sitting down here, and I try to remember, I think it can hold about 20,000 liters of water. Unfortunately, I was not able to open it. They say that there is a leak, and this has to be fixed if we want to use the resource of the rain falling onto the roofs. After the storage, there is a pipe going here. That is another water cycle that can be used in the garden. This is the first inspection manhole. From here, we can decide whether the water is pumped from the cistern or from the fountain. There are 2 water cycles in this garden. One coming from the fountain, the other is the rainwater coming from the roofs. If there is rainwater available, we should use it first, because it has a neutral pH and it won't block the drippers of the irrigation system. This is the pump that can be used to pump the water, the rainwater from the storage up into the garden and also into the forest, to the trees. It can push the water up 55 meters in the altitude. This almost reaches the highest point of the project.